Hello, everyone. Welcome to ASQ 1106 March section meeting. We're glad you joined us today, and we are excited to have Adam Bennett educate us about computer vision AI for industry, making sense of visual data. With that, I'll turn it over to Adam.
Yeah, thanks. Thanks for having me. I'm excited to talk about this topic. Hopefully you had a chance to read my little bio and obviously the abstract. But if you hadn't had a chance, I won't bore you with my background, but I'm excited about this talk because the last 11 years of my career have been focused on emerging technologies, particularly focused on vision technologies in industry, mainly manufacturing. And in the time of working with various technologies, again, particularly vision, there's been a lot of talk around, digital transformation. Now, industry 4.0, and now it's turned into quality 4.0. And, in that, the concept of capturing information, creating actionable insights, right, is really the idea, and to make things interconnected and more intelligent in operations, and how do we be more effective in everything that we do. And, interestingly, there's been a lot of different data types leveraged. If you think of like preventative maintenance and doing vibration monitoring or various other condition monitoring scenarios. But something that hasn't really been talked about a lot is visual data. So, which is ironically probably the most easily and abundant type of data that we can generate in operations. So I'm excited to kind of talk about this topic of computer vision AI for industry and how this technology can be leveraged to really make sense of visual data, leveraging various types of cameras and stuff. So, find the clicker. There we go. So, in the time today, what the goal here is really to kind of help the listeners, the industry experts, understand how you can be empowered with this type of technology, being computer vision AI, and the analytics it's able to provide off of visual data. So I'll talk about the capabilities of the technology, hit on some of the use cases and applications. But most importantly, one of the things I want to kind of start with is sort of differentiating the traditional machine vision technology that you may or may not be familiar with if you've seen cameras, inspection cameras in facilities. It's over the last 2-3 decades, it's pretty much been using what we call the rules-based approach. So I want to differentiate how that technology works versus the machine learning, deep learning technology, just fundamentally how that works and the value of that technology. So I'll kind of go into that. But first, before I do that, I like to kind of hit on I call it a fun fact. This might be something that's obvious or you already know, but it is a fun fact because it's something that can make you sit and think, particularly myself, because I'm in this world of vision and have been for several years. But it's interesting to me that the human body has 5 sensory organs, but 80% of all the impressions are come by means of sight. And so it's just interesting to me about the fact that high of a percentage is really coming from sight. If we're lucky enough to have good sight or have sight at all, if you consider all the sensory organs working, as they're intended to, and we're fortunate to have that situation. But the decisions that we make come from that much information coming from visual data. So it sort of begs the question, what if we could, leverage something that mimics a human-like perception, right? What if we could augment machine vision and supervisory systems to better understand what's going on in an environment? So maybe from a quality perspective, continuous improvement perspective, things going on in manufacturing, we could better define or detect and classify various types of defects, understand objects in space and where people are working, the actions they take or the actions they take with equipment, making that an event. So before I kind of dive into that, like I said, I want to hit on the idea or differentiate the technologies of traditional machine vision that uses this rules-based approach versus the deep learning technology and machine learning technologies, and really how that core tech is used. And then I'll kind of go into showing you the values of the things, the capabilities of what it can do. So if we look at the technology that's kind of been leveraged from a quality perspective and production, machine vision is something that typically requires some sort of expert in machine vision. There is typically like a controls engineer. And it depends on the company, because sometimes you have these different teams that are specialized to work with the technology. But when you're setting up cameras, it's been, pretty much a basic setup. You take a camera, you set up some lighting over your part, and that user then defines a set of rules based on how that camera was positioned, how that lighting was positioned, and really kind of the time of day, the whole scenario. And the rules that they define are fairly basic. It's you look at pixel counts and colors, gray scales, maybe shapes. You're looking at edges and patterns, and you define these rules based on what the camera sees, based on the resolution and the lighting and all the settings that you're going to set. And so basically the camera takes some images and it filters through these rules here, and you get your results. And that result is typically a go, no go, pass or fail scenario. That's great. And it can work in some pretty generic applications of just presence of things, right? Where you just have some basic inspections that you're looking to detect. But what we've been seeing in industry and what we've kind of run across is kind of applying inspections in more challenging applications. So inevitably what we end up seeing in manufacturing is you have variability. And sometimes you can take the traditional machine vision and it can handle some of that variability, changing colors of parts. But where it begins to get complex is when you're adding additional parts onto your production line. Maybe, the manufacturer won business with another company, and you can produce different SKUs on those lines, and you just have a lot more variation that's running on the production line. And then there's different things that you have to contend with when you're in the production environment. The real world is that we live in an age now where there's energy efficiency is top of mind. Companies are leveraging natural light. And when you start bringing in natural light into the environment, if you have cameras set up, they just start going haywire depending on the time of day, because you get high intense light coming in, maybe from sunlight, or maybe just the variation from cloudy days to sunny days. And then interestingly, things that I've run across is, a manufacturer who's been running only first and second shift, business is booming, but they don't have the capital to invest in entirely new production lines yet. So they add additional shifts. So we all know when third shift comes in, that's usually when things kind of go haywire. But the point is, once you really start introducing a lot of complexity and variables into those environments and variations of products, so high SKUs, right? This is where this approach begins to break down, and it becomes very complex to try to manage. And so as a result, one of the technologies that's been rapidly developing within AI is machine learning and deep learning technologies. And so I won't go into the depths of, the granular detail, but I'm sure you've all heard of, artificial neural networks. So you'll hear me mention, I'll try to refrain from using neural networks, and you'll probably hear me use words like models or detectors loosely, and they all represent the same thing. But the way that this technology works is kind of flipping the traditional way on its head, right? Just to kind of reiterate, the old way of using the rules-based, a user sets up a camera, you look at the way things are looking, and you start defining rules based on what you see. With deep learning, the way that this works is you actually feed the system examples, kind of like you would an operator. So if you're hiring operators to, manage things on production lines, and you're training them, hey, if you see these situations, this scenario, we got to stop the line. This is bad. You have to show them some examples a few times, some variations of those, or each type of example of things that you want them to see. So I call it the good, the bad, and the ugly. So you create those labels of what is good, what is bad, what is ugly, and you feed the system those examples. And what it does is it trains on that. It does computations, kind of takes the backwards approach of these are the results that I have to get to. So let me create a model so that when this type of data comes in, this image or a video, when it comes in, then I can discern, is this good, bad, or ugly? So what it does is it trains, and it basically, the model defines the rules based on what you show it that it needs to detect. And then once it's trained, you deploy that, and now all the data from your cameras comes in, it runs through those rules, right, that model, and it provides results. Now, the value of AI is that it's retrainable. It can continue to learn. So as you have variations, maybe your lighting variations, or maybe an entirely new defect type comes up. Your customer, it becomes an issue. Maybe there was no issue with, you were only seeing maybe potentially scratches on parts. And dings that you were looking for on a surface finish of something. But then all of a sudden you find that, we're seeing bubbling occur on the surface of this painted part. And we've got to be able to detect that. Well, now you can start giving the system feedback and add additional variables of things that you need to be able to detect. And then say you have variations of colors, right, of those surface finishes, and say 3 months from now, there's all of a sudden a new color introduced that you have to be able to do these inspections on. You can retrain these models to learn, just like you would a person, of, hey, now we're running blue, and they introduced this crazy orange color that we've got to be able to inspect. So now you can train that very easily to withstand or be able to understand. It's still looking for that defect, even with the variations that it's going to be seeing. And so another great value or part of leveraging this type of technology is that these neural networks or models that you manage for doing the monitoring of various things, and we'll go into what those types of things can be, you can create synergies across your different departments, your cross-functional partners across your company. So that could be, quality team. I just show engineering and production, and then different facilities that I work with. I see, maintenance involved, and different labels for people that are responsible for production. And so what you're able to do is have them be collaborators on this, so that everyone is on the same page of the challenges that you're trying to inspect for. And it's important to have everybody on the same page, because, when you're trying to inspect for something, we got to make sure, the people at production kind of understand, well, these are the things that are going to create these scenarios, and then they can get better information as a result. And we'll talk a little bit more about that. So that's kind of what I've given you there, is just kind of the basics of the differences of those core technologies. Again, traditional being this rules-based, where a user is kind of defining these rules. The deep learning approach is saying, hey, here's the examples of what I need to be able to detect, and I'm going to train this thing to understand, the good, the bad, and the ugly, and be able to tell me if that was good or bad or ugly. So with computer vision, what's nice about it is all it cares about is the data that's coming in is visual data. It's image-based or video, meaning it can also be a live stream. And it doesn't matter what type of camera technology that it is. It can be things like digital borescopes and microscopes, your typical industrial cameras that you see. It can be any of those, even security cameras, and various wavelengths. So X-ray, it could be shortwave infrared, near infrared, it doesn't matter. They all produce image files or videos, and you can leverage that with computer vision. So I like to hit on some of the things in the market that's really kind of been driving the demand for this type of technology. And I kind of hit on a few of them already, but if we start thinking about the idea of digital transformation and quality 4.0 in particular, the idea of, when you detect a failure, an issue, it's no longer good enough to say this is good or this is bad and that's it. We have to be able to get to the root cause faster. So if I can send information to someone that's responsible for a process and precisely tell them exactly what the scenario is, here, right, is a surface finish. We're looking on metals, is this crazing, inclusion, patches, pitting? If I can show and share that information live to the expert that's managing that production process, they're going to know what knobs to turn in the production process to prevent that from happening. And that's the idea, right, is to minimize loss, right, and waste. And this gives you that ability to get that deep analysis of what's going on in more real time. Also, other demand drivers have really kind of been the everything being customized from a manufacturing perspective. We're seeing, call it batch size 1 in production, but essentially everything being mass customized. So from apparel to a car, right? You can get online and select all the options that you want for your car, your colors, your interior, like everything that you want. And that option, right? There's so many different SKUs that it could potentially be. And, you do that with, as you see here, shoes, shirts. It's in medicine now. So we're doing mass customization of medicine, as well as food and beverage, right? Being able to do variety packs, right? So you have a lot of variation. And when you have to still do the inspections of these products with all of this variation, it's important to be able to still detect those various defects, even with so much change going on, right? Computer vision is able to understand what's important and what's not. And I hit on this one earlier, but the complex dynamic environments. So not just your lighting, but what's going on in the background, moving things that move or change. When you're working with traditional rules-based vision, it can't handle if there's just something different in the tooling that's just in the background of the image that you're capturing. And with computer vision, it's able to understand, what pixels, right? What part of that image or video is important and what's not. And then there's manual assembly operations. So we're seeing a lot in the market where we try to automate as much as we can. Things that are repeatable, mundane tasks that people really don't want to do. And it's hard to find people to do those jobs. So you're in effect forced to maybe buy robots and implement various automation. But some of the markets in manufacturing, it doesn't make sense to do that. It's cost prohibitive. And it's easier to keep people in because maybe you have low volume, high SKUs or whatever that may be. But it's still important when there's a manual assembly process to ensure that something was assembled properly, right? Or maybe in a proper sequence. And also there's kind of the challenge of, maintaining people. We're seeing people, jump ship from company to company, because you can get a pay raise. It kind of, it's logical. It happens. We all do it. But, once you lose someone that has been a great person on your production line that has this tribal knowledge and full understanding of the operations, whether they're in engineering or, an operator that's assembling things, they can visually look at things and understand, if I see this, then I need to do that, right? This condition means I have to adjust something over here. Once you lose that, it becomes very difficult. And with computer vision, you're able to kind of sort of maintain that tribal knowledge, if you will, because you're able to train a system when it's doing these inspections over time. You're able to help it understand the variations of things that you're detecting. So what I want to go into now is just kind of hit on some of these applications that we see in the market, and help give you kind of an idea and paint a picture of what can be done. So, kind of like what I was talking about earlier, about really classifying a defect. So I kept using the good, the bad, and the ugly, but if you look at like a welding process, if you're able to tell a welding engineer that, hey, we're seeing porosity, or we're seeing undercuts or burn through, spatter, whatever that is, then a welding expert who is kind of managing the line is going to know, particularly if it's like a welding or a robotic welding system, right? Maybe they need to adjust feed rates. Maybe they need to adjust gases, or currents or voltages in the system. They're going to understand precisely what they need to do. And now we get to that root cause faster, and we can provide, those responsible for those lines analytics on this, right? So first of all, if we have a defect, right, we're going to say these are good, these are good, these are good. Oh, we're detecting porosity. Maybe you let a couple of them go by, but as long as that individual responsible for that line is able to see in real time when and how often this is happening, they can make those adjustments. But also over time, you can capture analytics on these defects and understand, well, how often do we see porosity? How often are we seeing spatter, and help you get a better understanding of maybe what's causing these things, what adjustments happen, and are there some things that we can adjust in a dynamic fashion to prevent that from happening in the first place. And then, as I mentioned earlier, the types of camera technologies that can be used is just kind of illustrating some of these, from a non-destructive testing perspective. We're seeing companies wanting to invest in, implementing magnetic particle inspection into the process, doing 100% inspection. But in order to do that today, you have people in those cells looking at these parts and inspecting them with UV light. And as I'm sure a lot of you on here probably already know this, but with UV light, right, you don't want too much exposure of that, right? There's a lot of safety and risks and all this of having too much exposure with UV light. So you want to find a way to sort of automate this. And what's nice with computer vision is that, you're detecting defects that are varying in shape and size and location. And that's what the traditional rules-based approach can't handle. Everything has to be very particular and well-defined. But the reality is most defects vary shape, size, location. And if you have that variability, you need to be able to train it like we do operators, like people, so that it can understand what those variations look like. So we can you can take this and sort of define sizes of that based on your quality specifications. So if you say, hey, it has to be, this size or greater that we care about. If it's smaller than that, we don't, right? You can train these models in effect on those types of standards. But X-ray vision is used, and there's a new imaging technology that we're seeing, and I'm just kind of bringing this up because some of the stuff is just really neat to see what it's capable of doing. But this image and the next one, these are from shortwave infrared. So it's really neat because shortwave infrared light can look through opaque materials, organic material. And so here we can see a fill level right on a laundry bottle that normally you wouldn't do that visually. But this light can go through that. And same thing for like an apple looking for bad spots. So, I don't know about you, but I'm pretty picky when I'm at the grocery store. I'm not going to select an apple that has some bad spots, but that's something you really can't control. But it's interesting how vision can see through this and find these scenarios. I'm commonly asked, what's the smallest, defect that this type of technology can capture? And there's no defined answer for that. The reality actually is it's really based on the camera technology itself. So the imager resolution, the lensing selection, right? How well do we magnify it? And what's the surface area that we're looking, that we squeeze those pixels into basically observing. And so it varies. I know of companies using super low resolution VGA up to gigapixel imagers for mapping the stars and galaxies in the universe and everything in between. Work with biotech companies that are leveraging 150 megapixel imagers to look at things at a micron scale. So it's really just dependent on the cameras, right? If you look at like a digital microscope, you can see some really small things. And really all you're doing is just taking those images that it creates and looking at those pixels and defining what is it that you're trying to detect. This is an example of a lot of things that I've kind of shown you is what we call localization and classification. So kind of knowing where this defect is. So for instance, talking about the scratches or dents, right? So I can localize where that dent is and say, hey, this is a dent over here. Then there's things like what we're looking at right here, where it's just a pure classification. So you have a material and it's the whole image is of a material that we're looking at. So we can discern, different types of materials. And even if you're looking at a material and you're looking to tell if there's something else in it, for example, like paper products, maybe there's a particular fiber that can't be in it. So you can look at the entire frame, and if you detect the particular type of material, well, now you can basically segment that and start capturing an understanding of what is the percentage of that material that's in this frame. So other things are, kitting and assemblies. So even when from a kitting perspective, here's like a medical device product where, what's important is after it's completely packaged, right? We want to be able to make sure that everything is inside there. So with computer vision, you can train it. It's kind of like you and I would look at this and be able to see elements of a part to be able to understand, is everything in this package or not? So you can train it on things like that. And then, assemblies, we're looking at a circuit board. So there's all kinds of different, capacitors and resistors and IC chips or whatever that we can identify what they are, classify what type of chip that it is, and localize where it is on a board. So maybe you have variations of boards and there's certain chips that need to be on it. You can look at that and identify which type are where. So these images that I have here are, the purpose of this is showing kind of the complex backgrounds. So the image on the right is Mayo scissors. So you go into surgery with tools, and you need to come out of surgery with those same tools, hopefully. But what's powerful about the image that you're looking there is the material of the object in the background are identical. So this is stainless steel on stainless steel, and you can have tools obscuring the other one stacked on top of one another, and you can still identify and localize those objects. On the left, what you're looking at is a person holding a tool in a very complex dynamic background. So we're able to identify that object no matter if they're wearing gloves or not, or varying colors of gloves, right? Even with a changing background, lighting conditions are changing. And as you can imagine, things are moving, right? This is a production environment. They're about to carry out an assembly process. And so things are changing and moving, but it can still handle those dynamic backgrounds. So this is where it begins to get really interesting. So I've talked in the very beginning about we've kind of hit on detecting, defects or objects, but now we're going to get into people and actions and events. And so I'm going to kind of take you down the path of how we get there. And with computer vision, there's what we call pose estimation. So what you're looking at here is being able to identify the different joints of a person's body, right? Hips and knees and ankles, wrists and elbows, shoulders, eyes, ears, and we localize where they are. So we're saying this is a right wrist that's highlighted in green, right? This is a left elbow here in green. So what's interesting with this is that if we can start understanding the relation between the joints, we can start predicting the action, understanding what is the human action that's going on here. So this person is holding something. This person here is also holding something. They're holding an object, right? And you saw this same image where we identified the person is holding a tool. And so now you can create events. And what you're looking at here is, and it'll basically cycle a couple of times because there's a lot going on here. So what you're seeing is an assembly process where what's important here is to monitor a torquing sequence, right? So this is an engine. So if it's not torqued properly, gaskets won't seal right, bearings and shafts aren't gonna seat properly, and you're gonna have catastrophic failure. So it's very critical that the sequence of actions are documented, tracked, and done properly. And so that's what you're seeing here. So computer vision is detecting when a operator is engaging with the tool on the bolt. So the blue box there, we know where it is at that moment in time when the torquing action begins and ends. So we can say, hey, this sequence is done, and then they move over. So now we're tracking, right, XY coordinates of that. So we know that they went to the next sequence and so on and so forth. And so this data is captured and sent to an MES system. There's other things that we're doing with this application as well. You can, for instance, some of you may or may not know this, but in this exact application, operators aren't supposed to be wearing gloves. So that's actually a safety hazard. So you can tell when someone is wearing gloves and highlight that, like, hey, you're not supposed to be wearing gloves in this application. But also, if we know what sequence is happening, where that is, and when that's happening, now we can capture cycle time and correlate non-value add time, excuse me. And so that's a little bit of what this is. So what you're seeing here is a video clip of, someone assembling something. So this is just kind of painting the picture of what the technology can do. So, in production, from a continuous improvement perspective, the goal is to understand, right, what is our typical cycle time? And you're going to have a window, right, that operators need to meet within. So if it's too fast, that could be a problem. If it takes too long, right, we want to know why. And so what you're seeing here is a capture of that, right? You can understand when an operator is doing a task, and you're able to capture that time and how long it takes, right? You capture that, you store it, you're monitoring it, you pass it to MES, wherever that needs to go. If there's an operational anomaly, you can capture that. And with computer vision, since it's capturing that, you can do a playback. So you can get flagged of, hey, we had this anomaly occur, but now I need to go back and understand, well, what happened? So I can do a playback of the before, during, and after to understand, oh, looks like there's an issue with this component. Is this a repeatable thing? Is there something happening from our supplier? Or do we just have people playing around on their cell phone? Did they take a restroom break? Did they take off, right? So you're able to kind of get some insight. Is just this noise? Should this not be, this isn't going to really affect, production. It's just, that's another issue. So this is some of the information that you're able to capture with computer vision. Here is just another use case of, an assembly and a company wanting to kind of understand where time is pretty rough, but it just paints the picture of what's going on. So basically, you have a yellow dot here, which is using a detector to say this is a person working in an area, and we want to understand how much time is spent to do these various tasks, and they have to go to these zones doing this work. So you're able to capture that in real time and understand how much time is spent in each zone. And then now someone that's responsible for continuous improvement can go back with that type of information and understand, well, look, if we make these adjustments, we're able to reduce the time to this amount, which then means we're going to produce X number more of parts, which affects the bottom line. So it's kind of some fun conversations to listen to earlier from the last talk, where talking about ROIs and talking about, what information can we take to the C-suite, and having these conversations around ROIs and where losses are and waste and X, Y, and Z. And this is an example of a technology that can help you capture that type of information. So some other applications that the technology is leveraged for, right? We've talked about quality, we've talked about continuous improvement, manual assemblies, these defects, but also safety. So this is something actually just got published today, and but it's a really interesting application. This company wanted to leverage computer vision to help make the processes ensure they're safe for their people. So this facility has metal on these trucks, right? They have to offload things, and you're up high, right? You're 10 feet plus off the ground, and they have these airbags that are supposed to be inflated when they're working up here. So you're able to use computer vision to know when the trucks are there, when people are present, and what's the state of those airbags. So you can ensure that operators are doing work in the safe environment. And this was just something that I had as well, but just kind of the same point about safety and making sure. This is actually in the world of construction, where it's actually, if you ever go and pay attention to construction sites, you'll see security cameras mounted all over the place, and not just for security, but from a safety perspective. And what they're looking to do is make sure that workers are in fact wearing the proper PPE, but not just wearing it, using it properly. So being engaged with the safety devices in the right manner. So I've talked a lot about the technology, how it can be used. The next thing that I want to kind of just hit on here is the feedback loops. So what information are you able to get, and how can this be leveraged, and what value, right, from that perspective, can it bring? And we kind of hit on some of it, but when you're looking at manual assemblies, you can visually show operators what's going on. So in this case, this is a wiring harness, so we want to make sure it's assembled properly. So after it's wired, you step back, the image is taken from a quality perspective, making sure it was done properly. And if it's not, we're highlighting exactly where the issue is, so that someone can go back in, the operator can, and make the adjustments as needed. There's also feedback loops to the machines. Maybe you want to interconnect this to PLCs, MES systems, robots, whatever that is. So these are just a couple of examples of the types of defects these particular types of machines would be looking for, that for the machine, if it has that information, right, you can create a feedback loop for improvement. So if you're starting to detect short shots, right, and you're identifying that, well, now you can, the machine can adjust, pressure, temperature, time, whichever is required, that's creating the short shots. If you're detecting splits and cracks or scoring in the stamping process, if you begin to see scoring, that's a clear indicator that cracks are coming next. But now you can adjust speeds and lubrication potentially in those areas to help ensure that you minimize those losses. And then finally, I've kind of talked about, you're capturing quite detailed information, right? Even back one slide I mentioned on from a stamping process, detecting scoring and cracks, right? When we talked about welds, detecting porosity and detecting burn through or whatever. You're able to get analytics on this with computer vision, right? You can store that information. You can link that information to a serialized product, right? From a backwards check traceability perspective. So if there's a claim on something, you can go backwards and check like, oh, nope, that actually never happened when it was in our facility. That must have happened during shipping. Or maybe you end up finding, yes, actually, this was something that did occur and it didn't get addressed, but you can synchronize all of that together. And, a computer vision system is typically going to have like an API that can then interconnect with your QMS or MES, ERP, right? So on and so forth, and provide greater analytics on what's happening, or, tie into another system. Because what computer vision is going to do is give you analytics based on what computer vision can do. But maybe you have a better holistic approach of, well, that visual data is important, but it's only a piece of a grander thing of data that we're trying to collect of our processes. So we want that information. Maybe we're going to tie it into Power BI or some other system, right? So that's something that you can integrate computer vision with. So here's just kind of an example of, getting frequencies of when things were detected. For instance, we were actually looking at the application with the airbags being inflated and deflated. So you would be able to see from those streams when deflated or inflated and how often, right, those airbags were detected, and how often or when trucks were detected and people were detected. So you're able to capture those analytics over time. And as I mentioned earlier, right, you can do video playback. So a scenario happens, right? A detection was made. For instance, we're talking about cycle time. So we create that anomaly of we're outside of this window. So let's go back, look at that snapshot in time and understand what happened and do a full video playback. So then that's what we're looking here. So actually, I just had a little bit of fun with this, because clearly, I can't show real world things. So my real world that I wanted to detect was something associated with my kids. But if there is a detection going on or an inspection that I'm looking for, I get a snapshot in time of when did that happen. So if I want to dig into that because of a scenario, I can click into that and I can get a snapshot in time of this situation of when this detection was made. And what I did is I set up a camera in my house and I set a candy jar at the edge of the counter. And I was curious how long it would take my kids to explore and get some candy. So I ran a person detector and the pose estimation. So I wanted to know when they reached into the jar, right? Not just that someone was there. I thought it was cute to kind of see when did a person come into the scene. And then I wanted to know when did they actually stick their hand in the cookie jar, or candy jar, I should say. So then what I'm able to do is get this playback. So from that scene, it's now playing. And now I get to see, oh, my daughter came in and got her candy. And oh, by the way, there comes my son, decides that he's going to get his. But hilariously, she took a handful and he only took one. So it's kind of funny, but. So talked a lot there and about computer vision, and hopefully that gives you kind of a good understanding of how the technology works at a fundamental level and the ideas of how it can be used, from, detecting various types of defects and really classifying them, right? So that you can get to the root cause of challenges, and being able to provide analytics on that, how often those scenarios occur, and doing more with it. So being able to monitor cycle times, non-value add time, so that, continuous improvement objectives can be executed in the right places. And the other thing I want you to kind of take away from this is you can use any type of imaging technology, any types of cameras, as long as it provides an image or video file. And of course, you have enough resolution and frame rate to capture what it is that you want to capture. Computer vision can help you make sense of that visual data. So with that said, I think we've got a few minutes left. That kind of concludes what I was excited about presenting, and leave it open for the questions.
Thank you very much, Adam. I am going to stop the recording, and so anyone that wants to ask questions, we will do so after the recording is stopped.